Well, I don't know about you, but I sure enjoyed that. Welcome to Sunkworks, episode 57, right? Is that what we're on? Yeah, let's see. Hold on a second here.
Are we live? I think we are live.
That's episode 56. Wait a minute. How do we get back there? There we go. It says we're live.
There
That's
we go.
good. It says we're live. Okay. All right. So, let's see here. I put this out of the way so we can read the show notes. You can pause it and read them if you want. I'm not going to read them. I've got a bunch of links here. Let's see. So I wrote some code with ChatGPT, and it took way too long, and it didn't work very well. However, I learned about a new tool. It is called Cursor, and it was a much better experience. Here, you can see what I did. Here. So, what we're working on today is a Ruby app. It's not very big or complicated. It's just going to do a very simple job. I'm writing this as part of one or more CFP proposals, and we'll see some of what I hope to present at RubyConf Chicago. But I will be much more organized in November because at this point, I don't know how to do these things. I just surmise that they're possible. So, I mean, I've got high confidence that I can present it. I've presented similar topic before. Remember OSS Summit? It was a talk called Exotic Runtime Targets. Check it out if you want. So there's a couple of different things. There's a couple of ways we can go with this. One way we could go is to say we want to run WebAssembly. All right, so wait, back up. What was exotic runtime targets talk about? I decided that I was going to follow the trail as far as I could for Spin and other WebAssembly tools in Ruby. And I figured out pretty quickly that if you've really done your research about WebAssembly and why you want to use WebAssembly, and you've done the math, you probably aren't using Ruby in your WebAssemblies. But that doesn't mean we as Rubyists cannot take advantage of WebAssembly for plugins or for what else? I don't know. But we use plugins to build a Kubernetes operator. So there's a I'm not going to go into detail about it. You can watch that talk if you want to know what we built then. We're building something totally different now. So it's going to use, hopefully, I think, Spin to launch a few different modules. I think that we need more than one Spin app or Spin bundle. I don't know what you call it exactly. Spin.toml. I think we need more than one because I know that you cannot mix trigger types in the same app. So if I want 3 different triggers all to talk to the same Redis instance, then I think I have to set up 3 different Spin apps for that, which I'm not sure if that's true. So anyway, we're going to try to build this again in Spin. All right, so I already built this once last night. I built it in Ruby because I wrote in my CFP that implementation of this task in Ruby is a trivial exercise or something to that effect. So I, obviously the next step had to be go actually write the thing in Ruby and figure out what properties you want it to have. and make sure the tests pass, right? There should be tests of some kind, and you should be able to use it for the purpose intended. Like I don't need to take it all the way to production, but it needs to be ready to go to production. So we can compare our spin app or apps when they're done and say, does it do the same job? Does it do it better? Are we more or less performant? And what have we learned in the process? Have we made our code qualitatively better? That's my hope. I think our code will become better through the use of WebAssembly modules, and partially by taking things out that are implemented in Ruby that might be better implemented in another language, and partially by taking Ruby out of the picture altogether. We don't need Ruby processes at runtime in order to take advantage of Ruby, right? You've got your static site builders. You've got lots of ways we can use Ruby in build pipelines or other places. I don't want to minimize the importance of Ruby, but I'm here to talk about WebAssembly for Ruby. And I need to prepare you for the possibility that at the end of this, we're just not going to have Ruby anymore. Like, we did our prototype in Ruby, that's great. And then we decided it would be too expensive to deploy it at scale. So we flipped it to make WebAssembly, knowing what we're getting into, and then we got to the end much faster, right? That's what we're always looking for. So the code is simple. It's just a couple hundred lines, and it is a little bit complex as well because it uses threads, because I don't want multiple processes, right? So in our spin app, we may have to have multiple processes because that's how it works. But in our Ruby app, we absolutely do not want to have more than one instance of the Ruby interpreter running. So we're going to jam things together and make sure that we do the job. So what is the job? It's a really pretty simple idea. There is River app. River Data Explorer, I think, is this repo. A friend of mine is building. Is this the one? Yeah, I think we're in one of these branches. Oh, hell, let me pull up the Slack thread. I'm not sure where it is. So there's a front-end service that hits a back-end service, right? This is really easy. We've certainly seen this pattern lots of places before. And here, I think I saved it in my later in progress. A message you saved was not found. How? Wait a minute. All right. Yeah. Okay. Here. So this is our pseudocode that informed the design. So it's really simple, right? We just have a web service we want to hit. We want to save the output, and then we want to serve up the output rather than making the user download it from the backend web service, right? There's a few different goals here. To make this a good user experience, we need for the user to not be waiting for a database to pull a bunch of data together. It takes about 3 seconds to build this file. It's an 8.5 megabyte file. It's data all the way back to 2000 up to the current date. And it's going to change at least once a day. We really don't care if it changes more often than once a day. We can serve up day-old data, that's fine. And we want to make sure, additionally, I've added this, that not only does the user not wait for the backend service all the time, they shouldn't be waiting, they shouldn't be re-downloading the same content over and over again either, because bandwidth costs money. That's the most expensive thing. Once we optimize all of the CPU and memory performance, right, which is what we're probably going to get out of WebAssembly and making our problem much smaller, we're going to make the startup and shutdown times as fast as possible. That's what I meant when I said earlier about doing the research. And the Ruby interpreter just takes a full second to start, right? And it might be less than a full second, but it's way more than 10 milliseconds. And if our performance budget is like in the range of 10 to 20 milliseconds, we need it to start faster than that. Or even if it's right, if it's 100, if our performance budget is 100 milliseconds and it's entirely blown by the startup of the Ruby interpreter, that's a problem. So we don't need the solution to be in Ruby, but we're hopefully presenting at RubyConf, right? So we're going to do it in Ruby first, or I already did it in Ruby, and I've done it to a standard that I think is good. We could deploy this to production. Well, let's see it run here so we understand that it's good. I think that's all I need to do. Okay, so there's a data endpoint, which serves up pretty quickly, less than a second anyway. We can watch the network to see how fast that actually is. I think it was maybe a full second. Yeah, it was just over a second. So that's because it's downloading from right here in my office, so it's very fast. 8.5 megabytes will probably not be that fast for most users, especially if it's coming out of here, where we could run the service on Kubernetes. What I think we're going to do, because we've optimized all these things and we're talking about using WASM and Spin, is we're probably going to use Fermyon Cloud, which is not open source. It's a paid service. There's a free tier, and we're going to use the free tier, so that's great. We alternatively, we could host it ourselves on Kubernetes with WASM using Spin Cube. So I'm not going to do all that because we've already done a Kubernetes operator last time. We've already had one Kubernetes, but what about second Kubernetes? No, we're not. We're going to take a break from Kubernetes just for a little while. I'm not throwing the baby out with the bathwater here. I really like Kubernetes. I work on Kubernetes. Even since Weaveworks closed, I continue to work on Kubernetes big time. So we've got these little tiny goals here. We're just going to see if we can make these things happen. So what we didn't see here is that the cache was already populated when we started the server. But if we run IRB and delete the cache data, we need a Redis first here, then delete the cache data. Okay, and then we run the Ruby web service again. What we're going to see is the first time we hit it, it's going to serve up 202 very quickly because it's not ready. And then if we hit it again, it should serve up the data, right? And it does. That's great. So that's the requirement. And there are two small things we're going to add. And if we can keep, if we can do all this, well, we might not need that WASM app. I'm just kidding. We're going to do the WASM app. This is the easiest possible way to do it. And it might not be the best performing, or it might win in the end. I don't know. I don't think it's going to win. I think free hosting on Fermyon Cloud is going to win. But we need to make sure we take care of these things first before we start comparing apples to oranges, because if we do not solve both of the ends of this problem, then users are going to get a bad experience at least once. They're going to have a slow load time while they wait or for an error to resolve itself, and on the front end there will be a retry needed. We can avoid that retry in probably 99.9% of cases just by making sure cache is populated before the web service marks itself as ready. But I don't know how Fermyon does all that. I'm talking like this is going to be Kubernetes, and it's not going to be Kubernetes. We're not going to use Kubernetes style health checks. We're going to, because this is a spin app, it's going to spin up and then it's going to spin down after the request is done. And if you've seen any of the spin demos, the Fermyon folks put on a bunch of different demos. They have, I got one of these keycaps. It's really nice. Slats, I think is his name. Slats. So one small, yeah, here. So you check out some of these demos. They have really cool demos. But the premise of the demo is that, hey, look, these processes are so fast to start and stop. that we can literally spin up thousands of them, tens, hundreds of thousands in just a second or less. And we can afford every cold start. Will give us all the cold starts. That's the goal here. We're not going to use any memory or CPU when we're not serving a request, and that's going to make things so much better for us. So, in their example, well, okay, you can look at their example. They're leading the way here as far as I can tell. I'm really following their examples, and I will definitely be tapping their examples, the spin templates. Like there's one for Python, HTTP, I think. And then there is a slight twist. If we want to build triggers, Redis trigger or a cron trigger. Here, where's the cron trigger? If we want to build a trigger, then we're going to have to use Rust for the trigger. But I think for our business logic, that doesn't necessarily mean we have to use Rust. As long as we use a language that can export functions, we can export a function from Python, say, that has our business logic in it, and then we can call that function from our Rust app to decide without building the business logic into the Rust app. So it's going to keep us from having to learn too much Rust because I really don't fancy a compiler. I'm a Rubyist, right? But I'm going to do it because we want this thing. We really want to know how polyglot teams can work together. And if that means that Ruby needs to take a backseat once in a while until all these issues are fleshed out, I'm not sure there are going to be issues. We'll see. But we know the way this is set up right now. It says right in the docs, you need Rust for certain things. So we're going to learn to do those things. We're going to learn just enough Rust to do that, following the examples. We're going to put together what we know in order to solve this problem without a Ruby process that stays resident in memory. We may come back and add a Ruby process that stays resident later. We can still get some of the advantages without WASM. Like we can start up and shut down when the request comes in, and not use resources when there are no requests. But because of the cold start of the Ruby process, we have some thinking to do about how to make that good. And I'll just point you at there's a HTTP add-on for Kata. This I haven't tried in a while, but it looks like it's still being maintained. Kata is the Kubernetes event-driven autoscaler. So we don't need this because we're using Spin. Again, there's no Kubernetes for us. We can put these things together. I know there's a doc in here that explains how to do that with a horizontal pod autoscaler or Kata. And like I said, the Spin docs are amazing. If you just look up Ruby and WebAssembly, you're going to learn so much. I really hope you read this doc. I sure did. I enjoyed it a lot. And I've talked about a pure Ruby solution in some of the docs here, if you saw the README. I'm saying pure Ruby, but I don't really mean it. I just mean that it's not a mix of languages to the author, right? It's just a single language. I have only written Ruby code here. If you go through all my gems, you will find some of them are using native extensions. So it's not technically pure Ruby, which also means that if you follow those docs we just looked at, you're going to find out nobody knows if you can package C extensions with your Ruby code, but you can package gems as long as they are pure Ruby gems in the sense of the true sense of the word, pure Ruby that does not use C extensions. So we figured all that stuff out for the OSS Summit talk. We didn't show all of it, but it is all in here. If you follow the examples, I think there's a few examples that I've followed to try WASM time at one point, and then I learned about how it's compiling stuff in the background for you to take your generic WebAssembly and turn it into a faster thing that you can run on your particular hardware, which is one of the cool things about WebAssembly that you cannot really do in traditional C binaries. You can't take them and recompile them at runtime for whatever platform you're on right now, right? If you're on Debian Linux and you're running ARM64 distro, they have to, well, I don't know, ARM or AMD 64, they have to decide what minimum CPU they support, and they have to compile to that target. They cannot use opcodes from a higher version of the architecture, right? So if it's ARM v7 that they want to target, and they're compiling a single binary for distribution in the OS, then you're going to get a binary that supports ARM v7. If it's ARM HF, then it's ARM HF. It's ARM AArch64. I don't know, what levels of support there are for, but anyway, okay. So, yeah. So we did progress from WASM time to WASMer because I liked the docs better, and I did look at performance here. I'm going to go back and reread these notes. I don't remember what they say. Oh, looks like that file is gone. I don't know what happened exactly. But I do know that the gem we used last time has not been updated since like 2021. I can see it's 1.0 and it looks like that's it. And it didn't work for me on the latest Ruby last time I tried. So we're setting this aside. If we need to update this repo, we're probably going to remove all of the WASMer stuff. I don't know where it even is. My WASMer. Here we go. Yeah. We're going to take out all of the WASMer stuff, and we're just going to replace it with this. It's called Xtism. There's something called a host SDK or PDK. And oh, this is 1.0. That's cool. But it's 1.0 this year, not 2021. And it's still maintained. So I met these guys on their Discord a long time ago, and I said, wow, you guys are building exactly what I want, but what did I want it for? I don't know, some future conference talk. Maybe not even this one, because we're going to do, I think, a spin app. I still have room. I don't know that my talk is going to get accepted, so I'm still considering writing another one or two proposals. But we're right up against the deadline here. Tomorrow is the actual deadline, so I may just go with the one that I've got. I'm pretty happy with it. I think it's going to be a good talk. It's going to be a lot of fun to build. I'm not going to do it all on the stream today. I know I had lofty expectations in the show notes, but I really just wanted to walk through all this stuff once out loud for the benefit of my own recollection of what I did and what I'm doing. So I can come back and look at this later once I've changed everything to work a different way and see how far we've come. All right. So I think we are going to try to solve these two issues, right? I don't think it's going to be too big of a deal for us. I'm going to delete that cache again here. And we're just going to go in with Copilot, Copilot++ on this code tool. I'm going to take myself off the screen here and shut up. And you're just going to see me interacting with Copilot from now on. And then that'll be the rest of the episode. So here we go. So if that worked, then we should just be able to run the process, wait a few seconds, and then hit it. So I'm going to try to hit it. Well, no, I'm not going to hit it until I think the cache is probably full. And there we go. That worked. Okay, so now part 2, bonus points. Here we go. All right, it's time to see if we broke the tests. Yes, of course we did. All right. I'm not sure why this is broken, but I'm going to read the test and see if I can understand why. Test on 39 here. Might be helpful to add some debug logging in the cache ready method and in the test to see exactly what's happening. Okay, and then I think we need to set the log level to debug. I'm not sure if anywhere else is doing that already, but I'm just going to do, I'm not sure how this works here. Mini tests, run a single test. All right, so we don't need to set it globally up here, or do we? I don't know. We're just going to set it to debug here. Perfect. And then we're going to do what they suggested, which is run I don't know if this is going to work. This is the one we're trying to test here, right? Undefined method debug for an instance of my app test. Do we have a method debug in here? That is fine. That looks quite fine. And, all right, we're not going to save the debugger. I don't think the test ops are doing anything, but I don't think it matters. I don't think we are in the right place here. Line 42 is where we fail. Assert last response dot OK. I don't know. Why don't we get the debug messages in the console? Wait a minute. What happened there? What the hell was that? Oh man. I don't know what that is, but I certainly don't want that. Hopefully you can see I really don't care about code quality here. I really care about exactly one thing. I want this to work. And if it works, let's see. Are we having flappy tests actually? No, we just have one failure. It looks like it did just fix some stuff. So I don't know why it doesn't work still. We've got one error again. Let's see what it suggests. Hopefully it's not just bopping us back and forth between two states. I think Claude is pretty good. That's why I'm using Claude now instead of GPT-4o. Claude 3.5 Sonnet seems to be a little bit better at trying something else when it doesn't work the first time. that could be it. That looks reasonable. I don't know. It looks like the test passed and we can take the debug shit out. That's great. All right, I'm gonna do that now. Set log level. Put this back to perfect. I didn't remember what it was, but it was info. And now if we run the tests, we should just see that it passed. We don't, oops. Who is it? Who's there? I don't know what the hell's wrong here. I'm not that worried about it. If it doesn't cause a test to fail. So if you're still following, what we are trying to do here is make the download not happen again. We can see the cache state and whether the cache is good. We can tune the debugger all we want, but what I don't see here is any sort of timing. I don't know if there needs to be a TTL header that tells how long the cache should live, or what's happening to the cache. I don't know what etag, that looks like an MD5 sum. But we're going to try one more time with cursor here because we got the code committed. It seems to be working again. I just don't know about this one last issue. So we've got do not wait for a request if the cache needs to be populated. We can probably see that working if we delete the cache one more time and run main with debug. Or maybe not. I guess we probably should have set the logger before we even started any threads. Let's fix that. Yeah, where do the threads start? My app.start threads. Oh, we did set. So what about the threads? Are we just discarding that environment variable or what? I don't know, because it's definitely starting the thread. Oh, maybe not. You know what? Actually, it didn't start the thread. That's amazing. I have no idea why. Or the thread just doesn't know to emit debug messages. That's a bit weird. Ah. All right, well, you all can see what we're going for. I'm tired of streaming. I've been on for an hour and a half already, and I think you got the idea. I'm going to fix it because someone is actually going to use this, and we are probably going to go ahead and deploy the Dockerfile version on Kubernetes without any WebAssembly, just as Ruby. And I think that'll be fine. We'll find out. Anyway, that's all I got for now. Thanks for watching Sunkworks.